Hey, students of Seneca, how's everyone doing? Can everyone hear me okay? Welcome to what is the first ever live Seneca HyperStream. I'm very excited. I hope you're excited as I am. What are we going to be doing today? Well, it's the night before GCSE Chemistry Paper 1. So we're just going to have a nice, hopefully chill session going over some key stuff for the exam tomorrow. And going over some last minute tips and tricks. So let me know what you guys want to see and what's going to be useful. And let's dive into it. So what's the plan? So night before the exam, most important thing is to de-stress because you don't want to go in all anxious and stress about the exam. So we're going to go over some good tips for the exam to make sure that it can go as smoothly as possible. Going to go over a few key facts and principles from the night before course and go over a few exam questions. Nothing too heavy, but just enough to keep everything nice and fresh. There'll be a bit of electrolysis, don't you worry, and we'll be pushing for some 7 to 9 content too, but it's good for everybody. So we'll run through the course. Key things, we're going over atomic structure, states of matter, some quantitative stuff, chemical changes, energy changes, and then we'll end with a nice little stress buster. So it's going to mainly be based on the AQA course, but the stuff will be relevant for other exam boards. So especially like the exam tips and stuff like that. So tune in and stick around. It should be a lot of fun. So this is the first time we're doing it. So if there are any cute little hiccups along the way, sorry about it, but we'll just keep getting better and better. I'm gonna share my screen with you guys in 2 seconds, and that will be the basis of the stuff that we'll be going over. So is everyone ready? Everybody pumped for the exam tomorrow, or probably pumped to get it over with? The GCSE exam timetable is long. You guys are going to June, but it'll be over soon, and then it'll be a nice long summer, and it'll be great. Okay, so let's dive in. I am just going to share my screen with you guys if I can find the cute little button that will let me do it. Are there any topics that people desperately want to go over? Chuck them in the chats now. I saw electrolysis was floating around a few times. So that would be something we'll go over for sure. And then it comes up in the, in the energy changes bit. There's a nice bit of electrolysis. Let's find this little thingy. Any other topics, just give me a shout. Okay, so hopefully you should be able to see my little screen now, and we're gonna go over it. So, oh, and there's my face. Look, I can move it around. That's fun. And we'll go over it. We're going to start with atomic structure 1 to 2 markers. So atomic structure, super fundamental chemical concept. So it's a good one to go over for your exam. And hopefully I'll give you some nice little tips and tricks so you can go in and absolutely kill the paper 1 tomorrow. So we're going to start by going over alkali metals. And which of the following are alkali metals? Well, remember, alkali metals are always in the group 1 of the periodic table. So it's stuff like potassium and lithium. Boom, okay? Now, a question that comes up a lot is about reactivity of metals. So you might get asked, why is potassium more reactive than sodium and lithium? And things to remember with this, like with any metal, the reactivity of a metal is determined by how easily it can lose an electron. So when it comes to the alkali metals, potassium is going to be more reactive because that outer electron is further away from the nucleus. Remember, nucleus is positive. So because the electron is further away, it's easier to lose it. So boom, potassium is going to be super reactive. So outer electron is less strongly attached to the nucleus, and a nice little celebration gift to congratulate you for your hard work. Don't worry, bonding will be coming up. I see you in the comments. We'll do some bonding, and there's going to be a bit of, yeah, greater shielding. Thank you. Shielding's the word you want to use, especially if you're pushing for a 7 to 9. Shielding is the word you want to be using in your answer. Okay, which atomic model was devised by J.J. Thomson? Who remembers? Anybody? So it is the plum pudding model. Boom, and I even spelled it correctly. Bonus. The way I remember that, J.J. Thomson, it's 2 J's. Plum pudding model is 2 P's. So that's how I remember J.J. Thompson, plum pudding model. What do we call atoms with the same element that have a different number of neutrons? This comes up like all the time. I swear the example just loves isotopes. And key thing with an isotope, it's the same number of protons in the nucleus, but a different number of neutrons. And protons is that atomic number. Okay, what periodic table group is sodium in? So if I tell you sodium is an alkali metal, you should hopefully remember that it's going to be in group 1. Bam, okay? And next we're going over some alkali metal reactions. And all of them react with metal. You probably did them in your chemistry class. Teachers like to do them because there's fizzing and stuff like that, so it's fun. So you've probably seen them, but the key things you need to remember is when you have an alkali metal react with water, you're going to make a salt and you're going to make hydrogen. Oh, not hydrogen, what am I saying? It's just going to fizz. And you're going to make, we've got an example with magnesium, which is an alkali earth metal. And that's going to make magnesium hydroxide, and we're going to make H2. So which one's balanced? So balancing equation, I always just note down the amount of reactants we have on the left and the right. So if we look at the first one, it can't be that because we've got 1 mg here and 2 mg there. So next, we've got 1 mg here, 1 mg here. That seems good so far. We've got 2 hydrogens on the left, but already I can see we've got 4 on the right. So it can't be the second one. Next, 1 mg, 1 mg. Yep. I like that. That's pretty good. We've got 4 hydrogens on the left. Yep. And we've got 4 on the right. Ooh, and we've got 2 oxygens on the left and 2 on the right. So I think it's that one. Boom, easy. That was some real chemistry right there. I hope you enjoyed that. Okay, so James Chadwick discovered that some particles in the nucleus have no charge at all. What did he call these? Well, clues in the name, no charge. It's going to be neutral. So they're going to be neutrons. Boom. And which of the following is true about the relative mass of subatomic particles? Really important point to remember, when you're talking about the mass of subatomic particles, you have to say relative mass, because protons and neutrons have a relative mass of 1. And it's a relative mass because it's comparing. It's not like grams or anything like that. So you need to use the term relative mass. It's often underlined on the mark schemes in the exam. So it's a good thing to remember. And oh, I clicked the wrong one. So protons and neutrons have a relative mass of 1 and electrons have a negligible mass. This is why it's important to read the question and answers properly, because I saw the bit electrons have a negligible mass and boom, I was like, oh, it's going to be that one. Incorrect. Read the whole sentence, especially for the multiple choice questions. Okay, so that was a very quick run through of some key atomic structure 1 and 2 markers that you'll expect to see tomorrow. How was that? Was it useful? Was it what you were expecting? Let me know. Anything else on atoms that you want to go over? Anything else? No? Okay, so next we are going to go, what are we going to go over next? Well, we're going to do a little bit of states of matter, and we're going to do some hyper flashcards. Starting a new section, yeah, love it. So describe the particles in solids, liquids, and gases. Okay, 3 key states of matter: solid, liquid, and gas. Things you should remember: solid, the particles are really close together and they vibrate in a fixed position and they have a fixed shape and volume. Okay. Liquid, we're starting to get a little bit more fluid, so like the particles are still pretty close together, but they can move and flow randomly past each other. And liquids have a fixed volume, but they can change shape. So like, say you've got like 2 cups of different shapes, but they both have a liter capacity. You can transfer the water between them and they will still, the water will still have the same volume, but a different shape. And gases, they're crazy, they're far apart, they move randomly in all directions, and they can change shape and volume to fill any container. Awesome. And importantly, hair also has to have volume. Don't forget hair volume. Very important. Okay, state changes that occur due to heating. There are 2 that you need to remember. Melting, which is when obviously a solid will go to liquid, and boiling, which is when a liquid evaporates and becomes a gas. Now, if you're pushing for a 7 to 9, another state change that can occur due to heating is sublimation, okay? And that can be, it might come up as a suggest question or like a stretch question, and that's when you go straight from a solid to a gas. If you want to see what that looks like, iodine sublimates, and it looks really cool when it does it, because it's like this cute little purple color. So if you want to check that out, Google sublimation iodine, and that will give you an example of another state change that occurred due to heating. But that's only if you're aiming for those 7 to 9s. It's not something that's core syllabus. So which state does not have a fixed volume? That's going to be a gas. Solids and liquids both do, but remember, liquids can take that shape of a container. Okay, due to cooling, condensing, and freezing. So condensing, that's like when you breathe out onto glass and you get like that little mist, and then you can draw like a smiley face in it. That's when you go from a gas to a liquid. Freezing, that's when a liquid is cooled below its melting point and it freezes and becomes a solid. See, you've got this, not too bad. Nice little gif of Mulan there, great film, watch that when you're done, as a nice pre-exam de-stress. Okay, what's not true about solids? Okay, the particles vibrate, pretty sure that's true. Fixed shape, did you have a fixed shape? Fixed volume, change volume to fill a container, no, that is a liquid that does that, remember? Okay, 4 state symbols you need to know for the exam. Do you know what they are? Very good. So it's solid, liquid, gas, and aqueous. And aqueous, that just means dissolved in water. So if you take some table salt, put it in some water, stir that up, you're going to have an aqueous salt solution. Just means dissolved in water. Okay. So and again, this question is going to consolidate that super quick. Aqueous, boom. Okay, when does a gas condense? Do you remember the state change that is condensation? So that's when we go from a gas to a liquid. So we know it's going to be cooling. So process of elimination, we can get rid of the bottom one. It's not going to be warmed. So it's going to be cooled to its melting point, boiling point, or what's going to happen when a gas condenses. It's going to be cooled to its boiling point. Okay, and boom, that is the end of states of matter. And so that's a quick run through of the key stuff that's going to come up. So how is everyone doing? How is everyone's brain feeling? Hope it's all going in well. So, okay, just looking and having a little look. Okay, so what are we going to be going over next? Well, we've done atomic structure, we've done some states of matter. So I think we're going to go over quantitative chemistry. And we're going to go over a few key equations that you need to remember for that exam tomorrow. If any of them are scaring you a little bit or you're worried you're not going to remember them, I always used to just have like a really short list of equations that I needed to know for the exam that I would look over before going into the exam hall. Like in my school, we had to like queue up outside even if it was like really crappy weather and cold and we'd be waiting to go in, and I'd be looking at my cute little equation sheet. So we're starting with the mole. And moles, they're just a measure of chemical amounts, right? And 1 mole of a substance is 6.02 times 10 to the 23 atoms. That's a lot of stuff. And that number is called Avogadro's constant. Nice little reveal there from the GIF. And next we're talking about relative formula mass, and that's equal to the mass of 1 mole of the substance in grams. And for elements, this is the same as the relative atomic mass. So how many atoms are there in a mole? Hopefully you remember because we just went over it. It's going to be 6.02 times 10 to the 23. Okay, first formula. If we want to work out the amount of moles, we take the mass, that's got to be in grams, and we divide it by relative formula mass. The relative formula mass, you just get that by looking at a periodic table and looking up the element that you need, and then finding its atomic mass, and whatever the formula of the compound is, you add them all together. Easy, cute little BBC Earth mole. Okay, what is the equation for the amount of moles? Do you remember? It's mass divided by relative formula mass. Boom. Okay, another molar equation you need to know. This one is for solutions. And moles is concentration times by volume. Concentration is in moles per decimeter cubed, and that volume is in decimeters cubed, which is 1 decimeter cube is like the same as like a liter, so it's fine. Do the math. Okay, so if we wanted to work out the concentration, how could we rearrange this formula? So if moles is concentration times volume, how do we get concentration? Well, it's not too bad. It's going to be moles divided by volume. And you can use the units to help you there because concentration is moles per decimeter or moles per liter. So you know you have to do moles divided by liter. Easy. Okay, so this is a very important law for your exam. It's law of conservation of mass. So in any reaction, substances don't actually lose or gain mass, it's just transferred. So it might become a gas, go to the surroundings, whatever. So conservation of mass, important key principle to remember for the exam. Okay, corrosion of metals. This is more of a 7 to 9 topic, but it's still important to go over. The mass of an oxide produced during corrosion will always be larger than the mass of the starting metal because oxygen atoms from the atmosphere have been added. So this is something like rusting. Rusting is a type of oxidation, and we have a nice little GIF showing what's going on there. And like you can see, like it's obviously gaining mass, but that mass is coming from oxygen in the atmosphere. Uncertainty. Ooh, it's quite foreboding. Every chemical measurement involves some degree of uncertainty. Yeah, I feel that. I feel that. That is a good GIF for uncertainty. So, do we remember how the mass of the metal oxide produced through the corrosion of a metal will differ from the mass of the starting metal? Do you remember the oxide mass will be larger? Okay. So it's important to repeat the measurements from experiments several times and then calculate an average from them. This will reduce uncertainty. Really, really important. An important thing to remember as well, this is particular if you're aiming for a 7 to 9, is the difference between something like uncertainty and inaccuracy. Uncertainty is something where we can reduce by repeating the experiment because then we're more confident we'll always get the same results. Accuracy is to do with how whatever we're measured is being measured. So for accuracy, you want to be using like a calibrated thermometer or one of those scales that has like 2 decimal points rather than 1, because then we're even more confident in the value. But that's to do with accuracy, like how close the value is to its true value. And then uncertainty is to do with repeating the experiment and taking an average. Okay, nice little wrong word, getting through all the different modules today. So the larger the uncertainty, the larger the range of results you'd expect. Yep, that makes sense. It's important to repeat the measurements from experiments several times and calculate a mode from them. I'm not liking something in that sentence. Anyone know what the word is that I need to click? Gonna be the mode, very good. And what is the right answer? Awesome, yeah, it's the average, perfect. Okay, boom, done, love it. See, burning through this. So about 15 minutes through, nearly halfway. How's everyone feeling? Hope it's going well and you're feeling de-stressed and pumped for that paper 1 tomorrow. Next, we're going to be doing some chemical changes. And again, we're back to those flashcards, which were super requested. So I hope everyone's finding them as a good module. And we're starting with acids. Okay. Just need to keep hydrated. Okay, so what's an acid? So an acid is something that forms H+ ions when they dissolve in water. That's an aqueous solution, and the pH is less than 7. If you're pushing for a 7 to 9, they might throw in a question about strong and weak acids. Strong acid is going to be something that completely splits up to give hydrogen ions, whereas a weak acid only partially splits up and gives hydrogen ions when they dissolve in water. But don't worry about that if you're not going for a 7 to 9, but it could be like an extra thing they throw in if they're feeling super mean. Like as mean as the person who gave the lemon to that poor little baby. Okay, so we've done acids, next we're moving on to alkalis. So what's an alkali? Well, if an acid is a pH of less than 7, an alkali is a pH of greater than 7, and they dissolve to form OH- ions in water. So they're basic. An alkali is something basic, okay? So, oil rig. This is a really important acronym to remember for your exam. What does it stand for? Oxidation is loss of electrons and reduction is gain of electrons. Boom. Very important to remember. It's helped me out of a lot of sticky situations in exams. So, what term do we use to describe the gain of electrons? Well, if we just think back to oil rig, reduction is gain, so reduction. Boom. Okay, what are native metals? This is another common definition question that comes up in paper 1. And native metals are unreactive metals such as gold and platinum that are found in the Earth's crust as pure metals. So a lot of metals that are more reactive, we find them as an ore, so they're like bonded to a bunch of other stuff. Whereas native metals, gold, platinum, stuff like that, they're super unreactive and we find them as pure metals. So they are completely by themselves. And displacement reactions, they can come up a lot. And that's a reaction when a more reactive metal, which again, like linking back to earlier, reactive metal forms positive ions more easily, loses electrons more easily. and it displaces a less reactive metal from a compound. So little creeper over there. That is what a displacement reaction is. Okay, spectator ions. What are spectator ions? Well, honey, they're just there to watch. They don't want to get involved. They don't like drama. They're just like, oh, I'm just going to sit back and chill in this aqueous solution and see what's going on. So spectator ions, they do not change in their reaction. So again, a more 7 to 9 question might get you to write like an ionic equation for an exam. And in ionic equations, we get rid of the spectator ions. And they're exactly the same on the left and the right of the equation, which is how you can identify them. Okay, so we're burning through this. Do you remember the native metals? So gold, platinum. So just think native metals, they're expensive. Okay, what do we produce when a metal reacts with an acid? Okay, so I remember my chemistry teacher taught me an acronym for this. And that acronym is MASH. Metal plus acid is salt plus hydrogen, okay? So keeping to, if another question that can come up is like, what would you observe when a metal reacted with an acid? Now, observations, they are things that, like, they're objective, right? So you'll see them, you don't need to be a chemist to say what's going on. And an observation in metal-acid reactions is you see some effervescence, which is a fancy way of saying fizzing. So the hydrogen like fizzes off when you add the acid to the metal, okay? Redox reactions, we've already talked over a little bit. Reduction and oxidation, remember oil rig to help with those. Okay, 3 types of neutralization reactions to remember. So acid, carbonate, salt, water, and carbon dioxide. So acid and carbonate, acid and metal, those are the 2 neutralization reactions where we produce a gas. That's where we get effervescence, okay? Acid and oxide, salt and water. Acid and hydroxide, salt plus water. So all of them produces salts. MASH produces hydrogen. All of the rest produce water. And carbonates are special. They make carbon dioxide. Easy to remember because carbonate, carbon dioxide. Boom. Okay, so what is the name given to reactions where both the loss and gain of electrons occurs? Does everyone remember? That is a redox reaction. Boom. Okay, characteristics of the pH scale. We'll do this one to finish. The pH scale, that is just, what is the range of it? Does everyone remember? 0 to 14, it's a measure of how acid or alkaline something is. So 7 is the magic number on the pH scale. That's exactly neutral. So we're not an acid or an alkali. Pure water is neutral. And remember, if we go below 7, we're an acid. When we go above, boom, we've got ourselves an alkali, okay? Right, let's go over some energy changes. How is everybody doing? Is the pace okay? Is everyone enjoying the content? Hopefully it's useful. Okay, so let's go over some energy changes. HyperCram. It's going to be fast. It's going to be fun. So let's go. Okay, chemical reactions are exothermic or endothermic, and that's all to do with the transfer of energy. So in chemical reactions, energy is not created or destroyed, it's conserved, just like mass. So exothermic reactions, that's when energy from reacting chemicals is transferred to the surroundings, which offer increasing temperature as a result. Boom, nice little thermometer gif. So again, energy in chemical reactions, boom, we conserve it. Exothermic reactions include combustion, neutralization, and oxidation. I love how this card even specifies is combustion that we see in the following GIF. So that's just burning, so the surroundings are going to get hotter. Endothermic, they're greedy, they want to take all the energy from the surroundings themselves, so the surroundings decrease in temperature. So that's how you tell the difference between endothermic and exothermic. Key definitions to remember for the exam. So remember, it's all about temperature. Endo and exothermic reactions are all about temperature. So we've done the examples of exothermic. Examples of endothermic are thermal decomposition and the reaction between citric acid and sodium hydrogen carbonate. Okay, so do you remember some exothermic reactions? We've got oxidation and we've got combustion. 2 really important ones to remember. So the examples freaking love applications of chemistry. So one thing they talk about a lot is hand warmers, which are great in winter. I mean, I'm not gonna lie, but it's when you have like that cute little thing and like you like snap it and then like this exothermic reaction happens and like your hands warm. And that's actually all done by the wonderful process of ion oxidation. Who knew? So that's those cute little things. So you snap that and the crystallization of the salt solution involves ion oxidation. So that's where all that energy comes from. Okay, do you remember endothermic reactions? Thermal decomposition, that's the key one to remember. Okay, what type of reaction is the reaction between citric acid and sodium hydrogen carbonate? That is going to be an endothermic reaction. The other one you need to remember. So, like, it's always good to be equal. We've done an example of an exothermic reaction with a nice little hand warmers. So we need to do one about an endothermic reaction, and that is a sports injury pack. Can't say I'm very familiar with them. Sport was never really my thing, but it's always good to know about real-world applications of endothermic reactions. And that is the reaction of ammonium nitrate and water mixed in a pack, and that results in some instant cooling also. And the speed of this reaction makes the packs ideal for scenarios when ice is not immediately available. Ice should always be immediately available. You never know when you're going to need some ice. You could have someone come around for a drink, you could have like some friends over. Always have ice in your freezer. That's another tip to take away from this, not just chemistry tips, lifestyle tips too. Okay, so we're done with endothermic and exothermic reactions. How is everyone feeling about those? Good. Next, we're going to go over the stress buster. So we're getting towards the end of the session now. So just going to go over a quick few tips before the exam. Let me know if there's anything you want me to cover in the last 5 minutes. We've got 5 minutes left. So the stress buster. This is the drag queen guide to reducing exam stress, which is like my favorite thing ever. This is my favorite module, well, one of them. So first things, good mindset, really important for the exam. So shake away any negativity, like bye, you don't need it. Have a positive mindset and just be confident of the you've had so far and the work you've done and all of that kind of stuff. Remember, the storm is almost over. I know GCSEs are just beginning and you're only just starting your exam, but the sooner they're started, the sooner they're over with, and then you'll get a lovely long summer to enjoy and have fun and see your mates and all that kind of stuff. So even though it can be a bit draining having exams, you do get a nice reward at the end of it. So what are you going to do for the rest of the evening? I would say relax, maybe look over your notes, click through a few modules on Seneca, do whatever you need to do just to kind of keep a little bit busy, but don't stress out. Plan a really comfy outfit for your exam. I always used to wear these revolting lime green tracksuit pants for my exam, but they were so comfortable. So get yourself a cute little exam outfit and get into that exam hall and kill it with the look. And also take a nice little deep breath to get rid of any stress. Maybe have a little mantra to say to yourself if you do get a little bit stressed or anxious. So something like, I'm great, I'm going to be fine, the exam is almost over. And just repeat that over to yourself a few times. That can help to take your mind off any nervousness. That's what I used to do a lot too. And so take your deep breath and then walk into that exam hall ready to slay, okay? So that brings us to the end of the first ever Seneca Live. How was that for everyone? Any last minute questions about the chemistry paper 1 tomorrow before we end? Anything else you're worried about? Any more tips for the exam? Just remember to like have your bag packed for the exam the night before. I think the exam is in the morning, so make sure you have a good breakfast before the exam. Maybe some oats, something nice and filling. And just take a bottle of water, make sure you're ready, have your pen ready, all that kind of stuff. Okay, so a lot of people are shouting out for like bonding and electrolysis. What I'd say about bonding, all you need to remember are the 3 different types of bonding: ionic, covalent, metallic. Ionic, transfer of electrons, so you make a positive ion and a negative ion. Covalent, that's when you share, that's when electrons are shared. That's the most important part. And then metallic bonding, that is when you have the sea of delocalized electrons and all of the positive ions, okay? So electrolysis was super requested, so was fuel cell. So we'll go over a quick question together, just to get rid of that anxiety. So this is what you're going to get when you're given a cell, and cells are where electrolysis reactions happen. You need to have the electrodes and you need to have the electrolyte, okay? So something that's a suitable electrolyte is an electrolyte is just a salt solution, okay? So if we have a list like this, which one's the salt solution? Going to be potassium nitrate. So an electrolyte is always a salt. Okay, there was also some requests for half equations, so I thought this would be a good question to go through too. So we have a cell set up with 1 copper and 1 chromium electrode. And this is the ionic equation. Now, ionic equations, they show the transfer of ions or charge, okay? So Cu2+, we have a 2+ ion, and then you can see we're making Cu. And when we haven't got a superscript number here, it means that the charge is 0. So we have to add 2 electrons. So that is where copper, and when we add electrons, we're producing things. So that brings us back to oil rig, remember. Reduction is gain. So whenever you see gain electrons in the reaction. So that's what's happening there, okay? So if that's the ionic equation for copper, what's going to be the ionic equation for chromium? Well, if copper is being reduced, so it is gaining electrons, chromium is going to be oxidized. So electrolysis and cells are redox reactions. So we have reduction and oxidation happening at the same time. So here, chromium is oxidized, so it's going to lose electrons. So we go to Cr3+ plus 3 electrons. Boom. Okay. So another example to go over is the formation of water by combining hydrogen and oxygen. And okay, so we're forming hydrogen and oxygen. What's going to be the balanced equation for that? So again, just like before, you just count up the atoms on the left and the right-hand side of the equation and make sure that they match up. And it is the middle one that matches up in this case. Oh, and the reaction is exothermic. So now we get to look at a reaction profile, and another good thing to talk over. So reaction profiles, remember, exothermic reactions, they release energy to the surroundings, and energy is conserved in a chemical reaction. So that if energy is released, the products have to have less energy than the reactants. Boom. Okay, what's the name given to the minimum energy required for a successful collision to take place? Another key definition, that is our activation energy. Activation energy. Boom. Okay, so that was a quick run through of electrolysis and some half equations ready for the chemistry paper 1 tomorrow. And how I hope everyone is feeling good and pumped and excited for the exam. Maybe not excited, but excited to get it over with. We have a friend coming.
So sorry to interrupt, students of Seneca, but I just wanted to tell Jono that we can't see his screen.
You can't see my screen?
No.
How long has that been going on for?
Just a couple of minutes.
I
thought that the nice people would probably like to know.
Okay.
I just thought I'd let you know. I'll leave you to it.
Okay, well, we're wrapping up now anyway. Okay, so that was Richard, who you might know. Oh, that's so funny. I just saw him in the video. Let me see. I'm not sure what happened to the screen. Let me get up. Let me see. I said there might be some little technical difficulties because it is the first time we're doing this. Let's see what went on. I mean, we're pretty much at the end of the session anyway, but let's go. Oh no, it went away again. I think when you minimize it, it goes away. See, I'm still learning. You never stop learning. Okay, there we go. Okay, so I think we're back at sharing of the screen. So sorry we couldn't see that. I'd say the key things that went on were, this is the example of a cell. The key things, remember, we've got electrodes. We have the anode and the cathode. Anode is always going to be positive and the cathode is negative. Another acronym I like to remember is red cat. So reduction happens at the cathode, so red cat, and anox. So at the anode we have oxidation. So redox and red cat and anox. Electrolyte, that is going to be the salt solution. So anything that dissolves in water is that dissolves in water as a salt makes an electrolyte. So that's ions. So when you see like Lucozade that's like full of electrolytes, those electrolytes are just dissolved ions, mainly like sodium and like Cl-. Okay, and then these are the half equations. This is what they look like. It's just the Cu2 plus 2 electrons goes to Cu. I'm sorry about repeating this, but just wanted, I'm not sure if you can see my screen, so just want to be comprehensive. So just remember to balance the charges with your ionic equations, and remember that reduction is, oxidation is loss of reduction, and reduction is gain. Okay, so how is everybody feeling for the exam tomorrow? I hope this was a useful forum to go over exam stuff. I think I've stopped sharing my screen now. So hope it was useful and a fun way to de-stress before the exam tomorrow. I'm gonna stop sharing my screen now and then just wrap things up. So there we go. Okay, so how did everyone find that as a HyperCram session? I hope that it was useful. You're gonna be fine. And if the stress buster didn't work, just go through it again and take some deep breaths. Like a little bit of stress is good to help you remember things, but don't focus too much on it. Oh, escape, I'm now full screen. And good luck everyone for your exam tomorrow. Let's all just do like a nice little deep breath and positive visualization. Just visualize yourself like going to that exam tomorrow with all your stuff ready, taking some deep breaths, and going in ready to slay. You're gonna you guys are gonna kill it. Best of luck. Give me some feedback on this. Hope it was useful. What else would have been useful to cover? Like sound off on, send us some like Instagram messages or reach out on Twitter. Let us know what was useful and what would be good to cover for the next one. And if this was useful, we're gonna tomorrow run over a Seneca predicted paper for biology or chemistry. I think there's a poll on Insta, so make sure you vote, and we'll be going over paper 2 in preparation for the rest of the exam. Thanks so much for joining the first ever Seneca live HyperStream. I had a lot of fun. I hope you guys did too. Best of luck everyone for tomorrow. You guys are gonna be great. It's one exam down. And you're on that tunnel vision to summer. And let us know what other night before you want to do. I see physics is quite popular, so we might do a physics one. Let us know what else would be useful to cover the night before the exam. And good luck, stay calm. You guys are going to be great. Thanks very much for joining, and I will see you on the next Seneca Live. Bye. And deep breaths. Go get ready to slay tomorrow.